Hi everybody, welcome to this today webinar from Variscite and Crank. My name is Pierluigi Pastor, I'm part of the R&D of Variscite. Together with me today we have Scott Snyder, Head of Marketing and Partner Engagement from Crank, and Max Zapata, the European Field Application Engineer from Crank. Today we will go through the steps that you may have to integrate Crank framework within Variscite EDKs. Let's start. Okay, so let's start with the introduction, and we'll go through the twin families. This is the agenda. We will talk about what is a system module, impact of the GUI on the products. We will go through the storyboard that Crank developed on our evaluation kit. We will see the demo, and we will have some time for the question and answers. What about Variscite? Variscite is in this market since 20 years ago, with an extensive customer base and a pipeline. We have a stable supply chain because we have an internal production, and we completely control the manufacturing process. We provide direct support through the R&D 24 hours, 7 days to our customer. Since a few years, we are NXP Platinum partners, so we have early access to both the hardware and the software. We provide a very extremely diversified IMX portfolio, so we have basically all the SoCs provided by NXP. We grant the highest quality standards meeting strict regulatory requirements, including those that may be required for the medical standards. We can rely on an ecosystem of partners for a complete end-to-end solution. So whenever our customer needs help, we can share the knowledge of our partners with our customer. Which is the advantage of using Variscite? Mainly, we provide two pin-to-pin families. We will go deeper in these details in the next slides that allow to migrate easily to the next technologies that will be available in the next years. We have a completely solution for the sound customization, 100% held all the time. All our hardware and software is production ready. It's tested by hundreds of customers, and we are aware now that the reliability is extremely high, and we provide a very low risk to the customer. We provide free support to our customers through the customer portal, GitHub, VariWiki, and the CID documentation. In terms of longevity, we rely on NXP, so whatever longevity is provided by NXP, usually not less than 15 years, is available on our songs. This applies both on the hardware, but also on the software, because whenever a change is impacting even a very old DSP, we provide the changes related to these old DSPs. Now let's talk about the pin-to-pin families. We provide, as I said, two different pin-to-pin families. The first one is the Variscite family. They share the same sodium connector. And for these families, we have the 6UL, the 6 into form factor, all the 8 families, so the 8M, the 8 quad, with all the various subfamilies. We introduced recently the TI IM62, but also the newer NXP MX93 and 91. All these SOMs share the same board, that is the Symphony board. So basically, you just need to change your software image, but you can still reuse the same hardware. These allow you to both, on one side, that you can tune the product according to the resources that you need in terms of power of the CPU rather than features of the SOM. But you can also escalate in the future, so you can use old SOMs like the 6UL, but even the newest IMX93. Something similar happened for the the Dart family. The Dart family is sharing the same form factor and connector. They have on the back 3 high-rhosis connectors, so they expose some more pins compared with the Variscite family. The reference board is the DT8M custom board because it was originally designed for the Dart MX8M. But even in this case, you can just unplug the SOM, plug another SOM, change the software, and that's it. For this family, we started with the 8M. We upgraded as soon as NXP released it with the 8M Mini and the 8M Plus. We are nowadays adding the IMX 91, 93, and 95. So also in this case, you can escalate in terms of features and newer SOM. Which is the advantage of using a pin-to-pin family. Mainly the scalability, because you can scale from one SOM to the other almost without other changes. Basically, most of the changes are in the software, but this is something quite obvious because we are talking about completely different chips. You don't need to redesign your carrier board while scaling, and you can optimize the cost because you can share the same carrier board for different products with different features. This make easy the development and the integration. Also, this will improve the lifetime extension because having the chance to jump to a new SOM, you can basically refresh completely your product. Let's spend a few words about what is a system on module. Basically, when Variscite releases a system on module, release this hardware that is fully integrated. It includes RAM, the eMMC, the CPU, and all the critical parts that are related to the tuning of the RAM, the boot process, and all the let's say the initial setup of the hardware is in charge to Variscite, and Variscite provide all the software for this SOM free of charge. It's publicly available. You can just reuse and simply customize whatever is on the carrier board. We provide a reference carrier board, but you can start from our carrier board, remove what you don't need, add what you need to specifically for your project. But let's say that this is something quite easy. You don't have to deal with the low-level process of setup of the hardware. You have a system that is specifically booting just with SOM. In charge to the customer, there's only the customization of the peripheral outside the SOM. Being aware that the SOM can be configured itself, so you can decide the size of the RAM, the size of the processor when available, the temperature grade. This helps the customer to fully customize the product and the feature of the product. And now let's talk about the impact of the GUI in a product success. And I leave the space to Scott that will lead this part of the presentation.
Thank you, Pierre. So when it comes to developing GUIs for today's embedded products, definitely things have become increasingly more challenging. User expectations have been elevated. Today's consumers expect intuitive modern experiences, not only from the physical device itself, but with its graphical user interface. The user experience has quickly become a defining part of today's products, with its UI being one of the main factors that it's being measured on, and what drives what value the consumers see in the product. Definitely integrating kind of evolutions in technology, no longer only gesture or voice-based interactions. And of course, any time lost or resources wasted or coding changes that need to occur can all create delays in getting the product to market on a time and of course on budget. Next slide, please. So definitely in terms of the UI UX for personal devices, the interface on, as you know, has its advantages, and definitely, you know, like I said, the functional aspects of it of a well-designed product really kind of has a tremendous impact for the business. For, you know, not only is it perceived to work better, but, you know, consumers look at it and just simply see it as being better as well. It makes users feel good about buying the product and validating their choices. And of course, for the business, helps to build brand loyalty for them. So definitely that's one of the main reasons why, you know, today's focus and many businesses are putting more focus on designing and crafting a well enhanced and a smooth user experience. Next slide, please. So if you haven't heard of Crank before this presentation, I can guarantee that you probably have used a product running an HMI or a GUI or UI, whatever you like to call it, that was built using our GUI development software, Storyboard. Crank is a software and services company that was founded in 2007 by a team of embedded software system engineers. Our product Storyboard has been used to create products around the world for small organizations and all the way up to Fortune 5,000 or 500 companies, sorry. So while we've received several awards along the way, it's more importantly is that the products that our customers have built have as well. Next slide, please. And so this is just a subset of some of the customers that have either trusted Crank's professional services or Storyboard or GUI development tool to build the UI for their product. Next slide, please. So now let's jump into talking a little bit more about Storyboard and what it makes it unique from other products on the market like it. Next slide, please. So when it comes to Storyboard, you know, the founders set out to build a framework that could help remove the inefficiencies of developing UIs that frustrated them and their colleagues. So what makes Crank Storyboard different? Well, it was architected to decouple the front-end UI development from the back-end development, making it possible to start developing early, making it easier to embrace the design iteration process that always happens along the way, and saving valuable development time for the creation of GUI applications that are optimized for exceptional user experiences. Furthermore, instead of having to code every button and every function from scratch, Storyboard supports the importing of native design files from Photoshop, Figma, or Sketch that enables developers to easily add core functionality to with a click of a button. So ultimately, Storyboard provides developers with a high-end tool, but with all the benefits of a low-code environment that can use to develop an engaging GUI applications for a wide range of target platforms more efficiently. Next slide, please. And so this is just an example of Storyboard's parallel workflow and how it enables designers and developers or different parts of the software development team to work on the front end and back end portions at the same time, instead of utilizing the traditional serialized development approach of traditional GUI frameworks. So instead of having to wait to hand off to your portion, both can be going on in this iteration process, really kind of crafting the perfect user experience. Next slide, please. So powerfully simple, yet sophisticated is what we often hear from our customers when discussing Storyboard. And the secret is, as I mentioned, is in Storyboard's unique decoupled architecture. So by decoupling the front-end GUI development from the back-end logic development, with Storyboard, both teams can work in parallel to build the embedded GUI application, thus making it easier for development teams to get started early on the UI development, making it easier to embrace design iterations that naturally occur, no matter what stage in the development cycle, and of course reduce the complexity of developing GUI solutions in an ever-evolving embedded hardware landscape. This makes the whole process of ensuring UIs perform as intended more efficiently, all resulting in getting to market faster with a product that provides customers with an exceptional UI experience. And so how is this done? And what are some of the key points? Next slide, please. So how do we help you really kind of accelerate development? Well, like as I mentioned, GUI to app development can begin within familiar GUI design tools such as Photoshop or Figma or Sketch, and then easily imported into Storyboard once the once complete, creating the building blocks of the UI application being created natively in Storyboard. Of course, this is not the only way. You can easily create it from scratch, importing the assets and building it up like normal foundations, or programming it all from scratch. But having that integration into design tools really makes it quicker and easier, and really removes the complexity of trying to recreate that design that a UX designer created within the tool manually by coding. So UIs can then be brought to life using Storyboard's integrated animation tool, allowing you to create, edit, and review animations all directly within Storyboard. And of course, integrated within Storyboard is our automated testing framework. So really having it within the development workspace helps streamline the overall GUI development process by making testing a more intrinsic part of the development process. And of course, test cases developed can be reused across projects and across hardware platforms. And then, of course, once the UI development begins, designers and developers can continue developing their portion of the UI application, leveraging Storyboard's parallel workflow. So design changes can be introduced back into the UI without impacting the current project or causing a complete teardown of the back-end code that was being worked on. And of course, project teams can remain in control of these iterations through Storyboard's unique graphical compare and merge tool, which allows them to select only the changes that need to be implemented into design, allowing for a more efficient, organized workflow when multiple members are working on the project together. And of course, Storyboard was created to be platform agnostic so that our customers can de-risk their projects by introducing a framework that easily supports technology and design changes at any point during the development cycle, allowing for GUI flexibility such as scalability, so the ability to kind of build using a single tool, build for MCUs or MPUs or SOMs. And then more importantly, portability. So allowing you to maybe switch out your technology stack, whether it's hardware or software related, as needed to take advantage of maybe new specific board features that are being introduced by Variscite when they bring out a new SOM. So this, and then more importantly, the reusability, so allowing you to take that GUI that you created on one project and reuse it across different product lines for maybe providing a consistent experience or brand look, touch, and feel for your complete product cycle. And then, of course, by leveraging Storyboard's simulator tool, teams can test GUI applications built for MPU or MCU or SOM-based devices, or test applications directly on hardware that is MPU-based, really allowing you to really find what's not working early rather than later in the whole development process. Next slide, please. So I just want to kind of change gears and just kind of talk about a couple of customers of ours that basically have, leveraged Storyboard or professional services teams in different ways. So the first is a leading manufacturer of commercial food prep devices that was looking to introduce a new series of industrial appliances for food preparation. And of course, what they were really looking for was they required a UI experience that scaled across their family of products and different hardware boards that they were introducing from different vendors, so that they could provide their customers with a common experience that was unmatched. And of course, the outcome was they were able to quickly develop a consistent user experience across different product lines via common UI that was developed once and deployed across the different ones with different tweaks. This way, they were able to streamline the customer's costs through reduced errors, reduced task load, and improved training, all via this consistent UI UX across the different multiple industrial appliances that they would find from the different product lines that they would have in their kitchen. Next slide, please. Another customer is a manufacturer of commercial laundry solutions for premier markets, including hospitality, healthcare, industrial, residential, and even military uses. So what they were looking for is they were looking to address the evolving client behaviors in their commercial laundry market by updating the experiences of their washer and extractor and tumble dryer products that incorporated a graphical touchscreen. So what they found is that a UI development tool that could handle the design and provide the development teams with the flexibility to make changes to the technology stack at any point in the current or future design changes in a cost-effective manner is what they required. And so by leveraging Storyboard, they were able to accelerate their design and development of their touchscreen-based products with the introduction of a nice, clean-looking modern UX with swipe gesture controls, similar to soft phones, or cell phones, I mean, something that everybody utilizes on a daily basis and has come to expect on modern products. And even more importantly is the feedback that they got from the people that deployed these was, it was easy to use, and it provided them the ability to provide upsells, which increased the laundromat revenues for them. Next slide, please. So why should you choose Storyboard for creating UIs for products you build with Variscite hardware? Well, like I mentioned, it's purpose-built for collaboration around the UI UX. It was designed specifically to help teams work closely together and iterate with ease in the quest for creating optimal end user experiences. Its low-code attributes really lower the barriers of entry for software developers working on the project, or even offloading the front-end design portion, development portion, to designers, while more senior developers work on the essential back integrations. This really helps you get to market quicker with an exceptional UI. Also, its rapid design and iteration and re-import technology not only does it allow you to remain in control of which change content you wish to accept and deploy before committing changes to the final design, but all actions and events that you previously established are reattached to the updated ones. Again, making the whole process of creating exceptional UI experiences for your Variscite-powered products more efficient. So, as they say, it's better to work smarter and not harder, and that's what Storyboard brings to the table. Also, like I mentioned, it's platform and OS dependent. So Storyboard developed GUIs can be deployed across different Variscite hardware simply by using the appropriate runtimes provided by Crank. So what this means is that we've done all the heavy lifting for you. We made sure that the runtime engines that are already created are optimized to work on that hardware, reducing the need for you to have to code and compile, code, test, compile, really making it more easier for you to move from one Variscite platform to another easily as your product needs change, or as Variscite introduce newer, more powerful platforms. And then last but not least, having this integrated testing framework into the development workflow means that teams can utilize testing more frequently in the development process, thereby catching issues earlier in the development and ensuring that your application functions as intended. Furthermore, testing the UI can be done directly on Variscite hardware, since they are NPU based, to verify the actual performance of the UI on the physical hardware. And so with that being said, I'm going to pass things over to Max right now, where he is going to kind of jump into Storyboard and really kind of show you everything that is talked about in real life, to show you the true value that and power that Storyboard brings to your development process.
Hi, I'm Max. I'm the field application engineer overseeing Europe. So today I want to show you some features of Storyboards that will help you to accelerate your process of development and deploying to your target device. So, this is Storyboards. If you haven't used it before, we have many cool features for creating animations. We connect to repos in Git. We have an automated testing tool and many others. But today I want to show you a couple of key features. Scott mentioned this before, that, as I mentioned, will help you to accelerate the development. And this is integration that we have with some designing tools like Photoshop, Sketch, or Figma. So today I'm using Photoshop, and I want to show you how, I'm just going to jump directly to Photoshop. So I'm going to show you how you can graph a design that you can have there. So this, for example, was created by a colleague of mine, a designer. I do not have any Photoshop skills. But if you have a designer on your team, you can let this person create those designs for you. And once this is created, you can go back to Storyboards. I'm just going to bring this here. And you can leverage our import function, in which you can grab those assets and pull them to Storyboards and you can start, like just from that base, giving some functionality to your UI. So as you can see, what I just did is taking this PSC file and I import this into Storyboards. Now you can take a look to the left, and there's a structure for this. So we have an application that contains different screens, that contains different layers, different groups, and different controls. Now, if you are designing your application outside, you will be using a naming convention for this, in which you name the objects in this way, underscore screen, underscore application. So once you perform the import, you will have this structure ready to work in your storyboards. Now, after you have this, you want to start building some functions. And there are a couple of ways of doing this. You can code everything, or you can use our wizard to quickly, for example, like you can right-click in this menu and select Add Action. So you can start generating those events that are going to trigger different actions. Now you see this summary here. This could be, for example, an animation finishing, if we are showing a screen, or if we are leaving a screen, if we are getting data from the backend. So all those kind of events can trigger different actions. In this case, I would use a press because it's the easiest way to showcase what I'm trying to showcase right now, which is basically that I want to press that with my finger and I want to go to a screen to a different screen. So there are some built-in functions like this screen transition that I will be using, and I can choose like any other screen different than the one that I am right now. And I'm going to do the same for this other icon, so we can see how can I play with that. So let's hit finish, and let's open the simulator configuration. So as Scott mentioned before, nowadays when you have to create it was the case for a long time. So when you want to create a UI, moving every pixel in your screen is a pain. So what we do is we have precompiled code that we call runtimes. That's basically connecting your front-end application and your backend. So it's going to be doing the job for you. We support many platforms. We support NPUs and MCUs. And in this case, I'm on a Windows machine. So I will be seeing the runtime for my Windows machine, but the concept will be the same for your Variscite target. So in this case, I'm choosing this application with this runtime. And in the Variscite case, you can take the runtime for the TI-62, you can take the runtime for the IMX8 or 6, and so on. We support software rendering and hardware rendering. So in this case, I will be using OpenGL, and I will just hit run. So I'm just going to save that. And you can see that an application is running. You see the whole screen, so you see the application popping up. Hope somebody can give me some feedback if you're seeing the application up.
Yep.
Awesome. So you have seen that I create those a couple of functions there. So now I can start just building that functionality. Keep in mind you can do this with code. So we support Lua and JavaScript on the front end. Now, on the back end, that's up to you. We support multiple languages, and we have a mechanism to communicate that we call SPIO, which is basically a channel, a full duplex channel that will communicate the front end with the back end in case you want to exchange information. We are not going to talk about that today, but if you are curious about how we do this communication between the front end and the back end, you can get back to me, and we can have a deeper look to that. So anyways, back to this demo. So we have an application now that we have created very quickly by just grabbing those assets from Photoshop and importing here and building some functionality. Again, keep in mind that we support Sketch for Mac devices, and we also are releasing Storyboards 8.1 this week. Actually, it happened today, in which we support Figma. So nowadays, people are working with Figma. So you will see those two options there. This is for importing from Figma, which is the same, basically the same that I show you right now, but we are connecting to the cloud. I'm choosing not to show that feature today because the only difference is that when you connect to Figma, you gotta pull the assets from the cloud. So that's gonna take a couple of seconds or minutes. So I don't wanna do that today. But keep in mind, we have the backend code is the same. So we have this integration available from Storyboards 8.1 being released today. Back to the demo. So what Scott mentioned is that this pain of performing iterations was always a huge one. And if I show you that I can move, for example, this icon and then just simulate this again, usually you will have to recompile. And in this case, I just gotta save and I have that icon over there and I can simulate again. So this allows me a lot of iterations very quick that I can be, that they are necessary to achieve that final design. I will get back to Photoshop very quickly, and I want to show you something very cool. So this is the first design that I have imported. So you see those icons there, this crank logo and this menu layer. And this is the second design of that same project, but there are some changes made. So now instead of having those icons, we have those layers there, and we have the crank logo above, and the menu layer is not there anymore. So I will get back to Storyboards, and instead of using the PSD function, I will be using the re-import function. What is going to happen is that now I can go ahead and grab that second design, and Storyboards is going to compare the new design to the previous design. Of course, as long as I don't break the naming convention, we are going to see the results here in this kind of Git style visual window, where I can see highlighted in yellow the new content that I can bring to my new design. And I will also see the differences between the old content and the new content if something has changed, and I can start bringing those changes into my design. So if I start checking those boxes, I will see the pre-visualization in this small window. I'm just gonna go ahead and select everything, and I'm gonna hit finish. By doing this, I will be merging those changes, and I can quickly test again, so I can simulate. And now you see the differences, and the two functions that I built before, they of course stay fully functional. So that's the whole idea of giving you the possibility of making as many iterations as you need. And from then, when you're ready to test in your target device, you can take these assets, put it on your Variscite device, and take the runtime that you need for that. And just like that, you will have this application running. I want to show you very quickly how the deployment works. So there are a couple of ways of doing this. So my Variscite target, so I'm currently in Germany right now, and the target device is in Canada. So I could access, I want to show you how to access, but then I want to show you actually a video we make last night because of the connection, it's taking a little bit of time. So let's go ahead and let's go to the simulator configurations. And there's a section here that's called Storyboards Target Launch Configurations. So I can create a new configuration there. And I have some presets here. So I'm going to be using, I guess, this preset over here. So all I need is the credentials. So I'm going to be logging as a root user to this IP address, which is a target device that is in Canada right now. And two things I need. I need my application. So by choosing this this thermostat 2022 final.gde, I will be grabbing all the assets. We can take a look to that, resources. So my application is composed by fonts, images, scripts, test files, and so on. And I will be grabbing all those assets, and I will be packaging this in something that we call JAPP, or graphical application. Storyboard is going to do that for us. And we also have to choose a suitable engine runtime. So for the case of the Variscite board that we have in Canada right now, is an IMX8. So this will be doing the job for me. This is the IMX8 Yocto Armely using OpenGL, but we have many others. And this is what we ship. Actually, we have many others that we don't ship because we don't want to make our installer that big. But you should know there are many options supporting hardware rendering and software rendering and Wayland and also DRM. So many options there. So once I have chosen my application, I have chosen the output directory, I have chosen the runtime and the output directory, I can leverage this legacy script that is going to be doing a couple of things for me. They are very simple. So first, it's going to export some environmental variables. So my engine, my application will know where to find stuff. So it's very simple. If I have a SV engine running, this will be killed, and we will launch the new engine. And then we're just going to make a call to the engine, which is basically a binary file that is plugin based. So we can pass different options if we need to. In this case, I'm just passing some verbosity. And if I run from here, of course, now it's going to take some time, but because the board is in another country, even in another continent. But Pierre, if you go ahead, you can display the video that we made last night to see how the deployment of this application should look like. Also, we are seeing here some timeout. This is because somebody disconnected the board in Canada. Sorry about that. But this is one of the ways. It's as simple as SSH connection. Otherwise, you use a normal transfer. You can use a USB stick, SD card. So whatever is at your hand, a simple copy paste of the engine, a simple copy paste of the application, and a script that is calling that engine, passing the options, and calling that application.
All right, so just some key takeaways from what we talked about. Definitely, you know, if you're looking to elevate the performance of your product, you can't go wrong with that. You can't go wrong by using Variscite SOMs. So whether it's the IMX 9 or 8, or even their new AM62 SOMs, can really help add the power and performance you need for your hardware. As well as if you're looking to create flexibility in your product, then you know the right products can make it easier shift from one technology to the other, and that's 100% what Storyboard was created for. And we offer a free trial for everybody, so definitely if you come visit us at our website cranksoftware.com/free trial, you have a 30-day free full functioning. There's nothing removed from it. That's including Storyboard Designer, which is what Max was showing you, as well as Validator, which is our testing product. You'd have access to that for 30 days. And if you need it longer, just reach out to us and we can extend it for you for a bit more, just so that way you can kind of really, you know, kick the tires on the development process and the development workflow for you. So with that being said, let's jump into any questions that you may have posted.
Hey, Scott, we have a question here. The question is, the story design application can be run standalone on Windows, Linux, and iOS platforms?
Correct. Yeah. So the actual development workflow, the IDE is designed to work on Windows, Linux, or on Mac. And so yeah, you can use any of those as your base OS to run Storyboard and create UIs on.
Okay, thanks. There's another question here. How would the communication work between Storyboard, one process, and the application, another process in the same MCU?
Sorry, are we talking about MC? Yeah.
So go ahead, Max.
So somebody's asking for MCUs. Okay, for MCUs is an inter-task communication, but probably it's worth asking actually for MPUs, because since we're talking of Variscite, we have been talking about MPUs today, but basically it's an inter-process communication. So you deploy your application and the engine, and you basically open a listener. So you will have a full duplex channel. So you will have another process. Let's say, for example, you want to read a sensor or something like that in your backend. So you have your board that is that has a process running there and is reading some kind of sensor, and you will have this information ready to be sent to the front end. So in that moment, you use a channel, what we call SBIO. So it's basically a listener on the application side, and you will be putting all the information in the channel that you want to display in the front end. And in the front end, we're event-driven, which means that when the information arrives, you can go ahead and do something. We don't do anything, at least we have to. So you can trigger an event, do whatever you need to do, and then you can send back information to the other process by using the other end of the channel. So it's a full duplex communication. Those are two listeners, and it's an inter-process communication. Does that reply the question?
I suppose, yes. One more question. If the runtime is pre-built, is there any build process, or are there files saved, then ready to go? Thinking about how this would be pulled.
Copy paste of the engine, and that should work out of the box.
Okay. The time almost gone, so let me just remind
before
our website. Yeah.
Sorry, before you move on, can you share my screen 1 second? I just want to show you the application running on the Variscite. It's a 10 seconds video that we made last night. So the same application that I had, I deployed it like I show you, and this went through our network to Canada and was deployed in a Variscite device. And if you allow me, let's say 10 seconds of sharing my screen, I will give it a run to the video that we made last night. So this is actually the application that I show you. It just was deployed like this, and this is the module, the Variscite module we have. And again, I didn't do anything else. I just grabbed those files from Photoshop, I create those functions, and I use the window, the export window, to give introduce the credentials of this board, and that's it. That's pretty much it. Copy paste of the engine, copy paste of the application, calling the engine, calling the application, and that's the trick.
Yeah, just on a note that remote feature, that function, the capability for teams to work like that was a lifesaver for many customers during the pandemic when everybody was stuck at home. So allowing teams to still work together, yet deploy remotely onto the hardware where someone had it locally at their house and were able to test the functionality so they could keep development going.
Okay, thanks, Max. Let me remind just the links. We have a website. You can contact us through the sales or our support forum. We have a wiki that is variwiki.com, and all our software is shared in GitHub Varigit.